We're solving linear equations, and these might be something that you feel really, really comfortable with, but you might not know why you're doing some of the things you're doing. So I want to go way back to a conceptual understanding of what they really are. I want you to think of what x really means. X represents some unknown number. It's variable, right? It could be any number. It could be 0, it could be 10, it could be 1 million. We don't really know what it is. It's just an unknown number. So we're trying to figure out what that unknown number is. So I want you to think of that unknown number as a cup full of pennies. We don't know how many pennies is in there right now, but we know that there are some pennies in there. So this equation might look a little bit more like this. We have 4 cups and we don't know how many pennies are inside of there. Then we have 2 negative pennies, right? Then we have 8 positive pennies over here. And we have a negative cup, meaning it still has the same number of pennies in it, but instead of all being positive pennies, they're negative pennies, okay? So what we're going to do is we're going to try to clear out this and figure out how much is in just one cup, okay? So to do that, we're going to create zeros, right? We're going to try to get rid of these pennies on this side so that just the cups remain. So to zero these out, we have to get rid of them, right? So what undoes a negative penny? Well, a positive penny, right? One positive penny will undo a negative penny. Ooh, that's not what I want to do. Hang on. There we go. So we have a positive penny. I'm going to put another positive penny. So this positive penny right here, right, when I add a positive penny to a negative penny, they cancel each other out. So these basically just cancel each other out and these cancel each other out. But we know there's a really big rule in math that if I do something to one side of an equation, I have to do it to the other. It keeps those scales balanced. So I'm going to do that. If I added 2 positive pennies to that side, I should also add 2 positive pennies to this side. So there we go. Now these are gone. We'll delete all of those because they zeroed each other out. Okay, and now we're almost to the point where we have just cups on one side and just pennies on the other side. So what do we need? Well, we need to get rid of this negative cup over here. So how do we get rid of that? Well, we zero it out with a positive cup, right? These two zero each other out because they are inverses of each other. But again, in math, if I do something to one side, I got to do it to the other, right? So I'm going to put one of those cups over here too. So these two are gone. And I'm left with 5 cups on one side and 10 pennies on the other side. So I know 5 cups is going to equal 10 pennies. So then I can just divide my 10 pennies into 5 groups, can't I? Right? So I can just divide these into each cup evenly. And I can figure out how many pennies. Oop, that one wants to go behind. That's okay. That one's going to go behind too. How many pennies is in each cup? Well, it's 2 pennies is in each cup. So 1 cup equals 2 pennies. So we can go back to here and we can say X, that cup that we don't know, was equal to positive 2. And I know that this seems really strange to think of it this far back, but truly that's why we do all of these inverse operations, right? Because what you might think is you know how to do this with algebra. We add 2 to this side to get rid of that 2, and we add 2 to this side, which is exactly what we did with the pennies, right? So those cancel out, and we have 4x equals negative x plus 10, right? And then what we did is we added a positive cup to this side to zero those out. That's what we're really doing. And we add an x to this side and we get 5x equals 10. Then we divide by 5 because we divide those 10 pennies into 5 groups and we get x equals 2. So you see how the algebra and the conceptual stuff actually marries together very nicely.